Okay, so what we're going to do is, you know that we need to do inverse trig to like solve trig equations. Like if I have sine x equals 1/2, you know, I would do the inverse sine of 1/2. And when you did like law of sines and law of cosines last year, we were using inverse trig. Usually for law of sines, inverse sine. For law of cosines, we did inverse cosine. So I kind of want to lead us through this. If I have y equals sine x, and I'm really going to go back in time here. If you graph the sine function, and anything I draw is what you should be drawing, okay? The sine curve starts at 0, goes up at 1, 0, -1, 0, and it continues to oscillate. And how I'm getting these points is from the unit circle. So every x and y is cosine comma sine. So that's where I got my points. So when we talk about inverses, okay, when we talk about inverses, an inverse has to pass the horizontal line test. And right now, if I were to draw a horizontal line through the sine curve, it would fail. And so what mathematicians have done is, there's actually infinitely many chops I could make. But if I chop the graph from -π/2 to π/2, if I just chop it right here, do you see that that piece of the sine curve would then pass the horizontal line test? Okay? So now understand, I could have done it from π/2 to 3π/2, 3π/2 to 5π/2. There's infinitely many. But in math, like if you think about it, we have to have order of operations, because if you just do stuff from left to right, and I do it by order of operation, we get two different answers. So it's like chaos if we don't have agreed upon rules. So mathematicians said, okay, in order for this to work, to do inverse sine, okay, so if I want y equals inverse sine of x, this is going to work and give me outputs between -π/2 and π/2, okay? So those are the only values that I can get. Oops, I mean y. Okay, those are going to be the only outputs. So then if I do y equals cosine x, and let me slow down here a moment and see if you can get this curve before me. If you think about this, okay, think about the unit circle. We're going to use it again here. If I want the cosine of 0, do you understand that that's 1? The cosine of π/2 is 0. The cosine of pi is -1. The cosine of 3π/2 is 0. And the cosine of 2pi is 1. That's where the numbers are coming from. Okay, so go ahead and plot them. The cosine of 0 is 1. π/2 would be 0. And then I just continue the pattern going to the left. So we have the same problem here, where if I try to do an inverse function, it fails because of the horizontal line test. So let me ask you this. Where can I chop it so that it would pass the horizontal line test? Okay, definitely. From pi to 2 pi, it passes. Where's another chop? 0 to pi. Another chop is negative pi to 0, negative 2 pi to negative pi. Well, the agreed upon chop is 0 to pi. Okay, that's what mathematicians have done. So, all right, now the tricky part is remembering these. And we're going to do tangent as well. But what I do, if I ever forget, I can just go back to the graph and see it, okay? And it's going to be the one nearest 0, okay? It'll be the one nearest 0. So let's do one more. Let's do the tangent curve. It's just really good review. So if I do y equals tangent x, well, tangent, I don't know what to do with that. So I stop and I think a moment and I say, okay, well, what do I know? I mean, that's what I just love about math is, you know, I feel like I'm this math detective and I get to figure stuff out. And that floats my boat. So I think, all right, tangent. What do I know about tangent? Tangent is sine over cosine. So I'm like, all right, I can work with that. That's a fraction. What do I know about fractions? Well, you can't divide by 0. And if you divide by 0, there's a vertical asymptote there. So I know there's going to be a vertical asymptote where cosine x is 0. Well, where is cosine x 0? You already have it on yours, but because I flipped my slide, let me draw it again real quick. Where is cosine x 0? That's here and here, isn't it? So that's going to be at pi over 2 and 3 pi over 2. So let's go ahead, 1. Now, do you guys also remember that the period length for tangent was pi? It's not the same as sine and cosine. Sine and cosine, it takes them 2 pi to repeat the pattern. But tangent only takes a pi length to repeat. So we're going to make a vertical asymptote at pi over 2. And there will also be one at negative pi over 2, because that's the same as 3 pi over 2, isn't it? If you rotate this way, that's negative pi over 2. Okay, so now we need some points. Well, let's think about what's the tangent of 0. Well, tangent 0, I don't know what that is, but I can sure figure it out. The tangent of 0 is equal to sine 0 over cosine 0. Okay, well at 0, sine is 0 and cosine is 1. So that's 0. Now what I taught my advanced math students or my pre-calc students is this. You make 4 tick marks and call it the period length of any trig graph.
Please pardon the interruption. All sophomores should report to the gym at this time. All sophomores to the gym. Thank you.
So what we're going to do, this is the homework. It's not bad. It doesn't take that long. Okay, so when you make 4 tick marks, if the second one is pi over 2, what's the first tick mark? Pi over 4. All right, so I'm thinking, well, what's tangent pi over 4? Well, you could do sine over cosine, but I happen to know this one. This is the tangent of 45 degrees. So the tangent of 45 degrees is 1. And then if I want to do the tangent of negative pi over 4, you remember the tangent is odd? I've been really hitting it with a lot of pressure in pre-calc this year. That's odd, so it's -1. And so here's the tangent function. And guess what? In this first interval from -pi/2 to pi/2, it passes the horizontal line test, doesn't it? So now, but do you understand there's like infinitely many, patterns of this? So y equals inverse tangent x is going to be defined from -pi/2 to pi/2. So this is going to be really, really important. Almost. And again, I know that I went back in time pretty far, but I wanted to cover my bases so that it's just good practice to know how to graph sine, cosine, tangent. So now let's get to the meat of what we wanted to do today, and this ties into 5.6. Everybody okay? All right, so to evaluate...
Should I shut the door?
Once Cheyenne gets in here. To evaluate inverse trig functions, here's what we're going to need to know. Y equals inverse sine works from -pi/2 to pi/2. Inverse cosine x is 0 to pi. And inverse tangent, and I'm not doing a typo or a mistake here. I want you to notice that inverse tangent does not have the or equal to's. Do you know why? What's happening at pi/2?
Asymptotes.
Asymptotes, exactly. So that's a problem for us. Okay, so let's go ahead and give this a whirl. See if you, and again, this is what you did last year in advanced math, no matter who you had. All right, so number 1, if I want to find the inverse cosine of radical 3/2, all right, if I want to evaluate the inverse cosine of radical 3/2, well, the answer is an angle, just like we wrote here. The y values, they're angles. So when you do inverses, and this is kind of this is super, super, super important that you know these conditions. If I want to find the cosine of what angle is radical 3/2, think about this. 0 to pi, this is first and second quadrant, right? That's first and second. -pi/2 to pi/2, do you understand that's first, fourth? And this one's first, fourth. All right, so you're going to need your 30-60 right triangle. You're going to need your 45-45 right triangle. And you're going to need your circle. With those 3 things and knowing all students take calculus, you'll be in terrific shape. All right, so cosine theta equals radical 3/2. What is the reference angle that gives me cosine of that angle is radical 3/2? 30 degrees. Okay, now, inverse cosine is either the first or the second quadrant. Well, when it's positive, it's first quadrant. If it would happen to be a negative here, like negative radical 3 over 2, I'm second quadrant. So, since it's positive, this is 30 degrees. And we do these in radians, so we'll just do a quick conversion that that's pi over 6. Okay, how about this one? Inverse tangent of 0. Okay, inverse tangent of 0. All right, well, I like to set them equal to theta and change the question. The tangent of what angle is 0? Well, inverse tan is negative pi over 2 to pi over 2. So that's not on either triangle. It's going to be on my unit circle. Tangent is sine over cosine. You understand that that's going to be, in fact, 0 radians. We're not going to do degrees. Okay, now I am going to do secant, cosecant, cotangent, and they go with sine, cosine, tangent. So in number 3, if I want to find inverse cosecant of 2, well, I'm going to set it equal to theta and rewrite the question and say, well, wait a minute, this is cosecant theta equals 2. But cosecant is the reciprocal of what trig function? Sine. So guess what you can actually do? We can make this, the sine of theta is 1/2, okay, because they're reciprocals. All right, inverse sine is first and fourth quadrant, so when it's positive, it's first quadrant. So what would theta be? 30 degrees or pi over 6. All right, how about inverse cotangent 1? So this would rewrite as cotangent theta equals 1, but cotangent is the reciprocal of tangent, but 1 over 1 is still 1. We just did tangent 1, didn't we?
No, the tangent 0.
Oh, tangent 0. Okay. Now, tangent, oh, I know where I'm thinking of the graph. We did do tangent of 45 degrees is 1, which is pi over 4. All right, so far we've only been in the first quadrant, and we're going to do one more. All right, what is inverse sine of 0? Well, this one is not in either triangle, but it is on the circle. And here's where you have to be careful. There's not two answers, because inverse sine is negative pi over 2 to pi over 2. So you can't get the 1 over at pi, because that's not included. So this is the sine of what angle would give me 0. And now remember, we're doing radians, so what would that be? Zero, right? Because it goes cosine comma sine. So it's between negative pi over 2 and pi over 2. All right, here we go. Now we're going to make it interesting, because so far they've all been positive, and positive is our first quadrant for all 3. So let's make it interesting now.
Could you have also called the last one 2 pi?
No, great question though. And the reason why you can't is because outputs are negative pi over 2 to pi over 2, and 2 pi is not in between those. Okay, great question. All right, so let's look at number 6. I have inverse cosine negative radical 3 over 2. So we're going to start it like we've done the other ones. We're going to say the cosine of what angle would give me negative radical 3 over 2. The problem is I can only get outputs, and this is what you might want to get in the habit of doing, is if you write them enough, like in class today and on the homework tonight, you'll probably have it memorized. So here's the deal. Inverse cosine is 0 to pi. That's first to second quadrant. So what I'm going to do is I'm actually going to get a reference angle this time instead of my answer right away. So this is in a 30-60 right triangle. It's going to be a reference angle of 30 degrees. But because the cosine of this angle is negative radical 3 over 2, it can't be 30. Does that make sense? The cosine of 30 would be positive radical 3 over 2. But I need to push this into the second quadrant, but it's 30 degrees away from the x-axis. Okay, 30 degrees tells me the reference angle, how far it is from the x-axis. So theta is in fact 150 degrees, which that's 5 pi over 6. Okay, let's do inverse sine of 1. So this is the sine of theta equals 1. Now this is first and fourth quadrant. Now be careful. When I say first and fourth, it has to go 0 to pi over 2 and 0 to negative pi over 2. I couldn't say 11 pi over 6. I couldn't say 5 pi over 3, okay? So sine of theta equals 1, that's up here. So theta is pi over 2. All right, so let's just change it up a little bit. And let's say I want inverse sine of negative 1. All right, well, we're going to set it equal to theta, and I'm getting the sine of theta is negative 1. Well, that occurs here, but it's got to go 0 to negative pi over 2, so that's negative pi over 2. Okay, inverse tangent, negative 1. So I'm going to set it equal to theta and say the tangent of theta equals negative 1. But this is first and fourth quadrant. So you're going to want to think about what's the reference angle, and then you have to put it in the proper quadrant. So what's the reference angle here? (45). This is a 45, but it's negative 1, so I've got to push it into the fourth quadrant, so theta is negative pi over 4. It's negative 45 degrees because I can't put 7 pi over 4 down. Okay, let's try this one. Inverse cosine negative radical 2 over 2. You guys, is this coming back to you? Do you remember this from last year? Okay. All right, so cosine theta equals negative radical 2 over 2. What's the reference angle? Pi over 4 or 45 degrees. But I need this to be inverse cosine is first and second quadrant. So it's 45 degrees away. So theta would be 3 pi over 4. Now, something I want to point out to you, so we're done with the notes here, and then I'll give you the homework to do, and you might actually get it done in class. Here's the deal. Inverse cosine x is the same thing as arc cosine x. That arc cosine or arc sine, that was like when mathematicians first developed it. And then probably in the last 30, 40 years, they've now been using that little inverse symbol, okay? That's a newer notation. Okay, because this is a pre-calc review, that's what this worksheet says, you're to do this without a calculator. So on the front, guys, on the front are the 20 problems you're going to do just like we've done. On the back, you're going to take that goldenrod paper and you're going to write them one more time for me on the back. Okay, because by Friday, I want everybody to get 100% on that quiz. Okay, so you're going to take your goldenrod paper and write the formulas on the back one more time. Oops, yes, I'm sorry when I said it. So you might actually get both items done in class. It's pretty short.